Okay, we're going to get to question 5 now on our topic assessment on differentiation. And the question says, you should be able to see it, a potter is making an open-topped vessel shaped, open is important, it's a right cylindrical cylinder, so that means it's at right angles up, and it says that the radius is r, and the height, which is handy, is 2r. So armed with that knowledge, I should be able to write out what the volume is in terms of r, and not have h at all, which is really handy. It says find the rate at which the volume, okay, so here we go, is increasing when r is 2 centimeters, and the increasing rate is, and it says here then, so it's r dt equals 0.25 centimeters squared. So I need to find this, I'm giving that. So if we look at it, we can see, well, okay, I got dv over something times something over dt. And I've already got the r dt, so I've already got that there. So that, job done. So here, that's going to be dr. So I need to find an equation with the relationship with v and r. So that's what I've got to try and find. If I can find that relationship, times it by that, when r is 2, I can then find the rate of the volume, the change of the volume over time. So I need to find a relationship between v and r, and that's how you do these questions, trying to find these relationships. And they told you at the beginning, they gave you that odd thing about the height here being 2r, because you can now work out the volume. You know the volume here normally is 2, is it 2? No, it's pi r squared. Get it right, Simon? It's pi r squared times h. That's how you normally write it, but if you already know that is 2r, so that's going to be, I'll do it slowly, times 2r, so that becomes 2 pi r cubed. And so now I've got a relationship between v and r. I can differentiate that. If I were to differentiate that, I would get, so let's just write this out, dv dr, just what I want, is 6 pi r squared. So now I've got all of this, let's bring it all together. So dv dt equals dv dr when r is 2, so it's going to be, so when r is 2, that's 4, so that's 24 pi times a quarter, which drops that back down to 6 pi. So there's my rate. If I wanted to do it using 3 sig fig, I'd do 6 times pi, 18.8. So my answer would be 18.8. So hopefully you know how to do that now. So that's part A. Let's now go to part B. So this question now, we are going to look, it says, given that the volume is increasing at a rate of 5 pi, so we've got that is increasing when r is 5, find the rate of the surface area increasing at this point. So now I'm introducing the idea of surface area. So if I look at surface area, it's going to be pi r squared, that's the base, so that's the bottom bit, and then there's the bit around there is going to be circumference times 2r, so that's going to be 2 pi r times 2r, which is going to be 4 pi r squared. You might want to slow down on that one, and that tied up becomes 5 pi r squared. 5 pi r squared. And just to remind ourselves what the volume is, it's always handy, it's going to be pi r squared times the height 2r, so we end up with 2 pi r cubed. 2 pi r cubed. And so the question wants us to find what is the rate of change of the surface area at that point. So I want the rate of change of the surface area. So this is what I want. And I now need to work out how do I get this. And it's a series of ones. I've got dv dt, that helps me there. So I can see already I've got dv dt. Do I have a relationship between dA and dv? No, I don't. So what I need to do is I've got to think, well, I've got dA dr here, and then I can times it. If you go through this, I've got to get a dv there and a dr there, and that's what I've got there, just a reciprocal of that. So here we get r. Working this out, I've got dv dt already. I've got to find the a dr. So the a dr is here. So if I differentiate with respect to here, I get 10 pi r. And here, we've already done this in the previous question, but it's the other way around. So I'm first going to do dv dr, and then do the reciprocal of that. So it's 6 pi r squared, and then just do the reciprocal here. That says when r is 5. So here, I know that's 50 pi, and work out this one here. So it's 25 times 6, which you just don't want to make silly mistakes here. So it's 150 pi, because that way you can make just utterly ridiculous mistakes. So now let's see if we're getting this right. dA dt equals dV dt, 5 pi, times dA dr, 50 pi, all over 150 pi. So obviously I can get rid of one of these pi's here. Just try and make life simple. I can divide by 10, boom. I can divide by 5, so I get over 3. It's a bit of a risk. Okay, so you might want to just put it all in your calculator, but let's just see. Whilst we're just learning this, we can afford to take a few risks. 5.35, so rounded to 3 sig fig is surface area, boom. And that's how you do that question.